other documents as well. I don't know why what happens, but 2 days it hangs and it crashes. Can you see my screen
Not yet.
now?
No.
No, hold on. I shared it already. Let me know when you see the.
Yeah.
Can you see?
No.
Okay, then let me stop sharing and share it again. Stop sharing. Share. Start sharing. Now,
No, it looks blank. You can see, but it looks like blank.
now.
No. Okay, let me end the call and I'll call you back.
Okay, yeah.
No, I can see the screen.
Oh, you can see it, yes?
Yeah, yeah.
Okay. So today we will discuss verification and validation. What is verification? If a simple thing before we start developing the software, we verify that the software we are developing is right. That is verification. Now we have developed the software. Now we are validating that whatever software we have built is right. Okay.
Yeah.
So the process, the testing activities we do before we start building the software is verification. Means we review the requirements, we review the documents. That is part of verification. Now we have the software. So when we have the software, we will execute the test cases and validate. Okay, we are meeting the requirements. That is validation. So what is the ISTQB definition? Confirmation by examination and through the provision of objective evidence that specified requirements are met. Yes, that is verification. So here he says confirmation by examination and through the provision of objective evidence that specified requirements are met. So in simple way we can say we are testing, doing some activities on the objectives, and we are verifying that they are met. Yes, how they are met? We are reviewing the process. So in simple manner we can ask the question, are we building the product right? You ask this question, are we building this house correctly? Yes. So this is the question you ask before you start building any software. What is validation? Exactly the same thing, but there will be a difference. Confirmation by examination and through the provision of objective evidence that the requirements for a specific intended use or applications are met. Yes. So he say that for a specific intended use, the software is built for a specific use and we are meeting it. We can get the answer asking, are we building the right product? What is the difference in here these two questions? Are we building the product right? So this question will be asked when you start it, yes? And when you are in the process of building, you ask this question. Are we building it right? Yes. So you are saying, are we building the right product? And the answers you get is the validation for that. So what is the intention of validation and verification? These both is to find the defect, yes. So we can verify that the product is going to meet the customer requirements. This verification and validation can be done on the products and the increments. Whatever product we are building, we have to do this activity. As for example, I said you have to review the documents for verification and execute the test cases on the system to validate the system. Any question?
No. Brijesh, are we talking about the V model today?
Yes, it is still part of that, but in testing activity, we do these activities, whatever model you follow. You have to do these activities. One is verification and validation. What forget about the models.
Okay.
Even if you do waterfall model, you still need to do these activities. You have the requirements, you are going to review them, write the test cases. In agile models, you have the requirements, but those requirements will be broken down into small pieces. Yes.
Yeah.
But in the small iteration, that activity should be done. You have the requirements, so you review. So you have the tech refinement in agile models. Yes. In the tech refinements, this is all the team members get together and review the requirements and try this is correct. What we are doing, what we are building as the specific and clear requirements, so everybody can understand. Yes.
Yeah.
So let's go to whatever testing you do. What no, what in whatever life cycle you need to do testing activity. Whatever testing activity you do in life cycle, you have to have some good characteristics for that. Yes, good characteristics of testing in any life cycle of testing in any lives. Whatever life cycle you follow, you will have to follow this, so it will be good. So for every development activity, there is a corresponding testing activity. Yes, for every development activity, there is a corresponding testing activity. So as we discuss in V model, exactly the same way, we have the component development, component testing, system integration, system testing, system integration testing. System integration specification means system integration testing. Business requirements, for that you have the business or acceptance testing. Yes. So each and every phase has its testing activity. Every test level has objectives to achieve. Each and every test level, yes. For component testing, you have objectives to achieve for component testing. For component integration testing, you have objectives to achieve. For system testing, you have objectives to achieve. For acceptance testing, you have your specific objectives to achieve. Test analysis and design of tests for a specific test level should begin during the corresponding development activity. Yes. As soon as you start this development activity, you have a corresponding testing activity, and that is test analysis and design. Yes. And this stands for early testing. How early testing? As soon as you have a draft document available, as soon as you have any requirement available, you will start building the test cases by analyzing them. So you start early testing. Testers should be involved in reviewing documents as soon as drafts available in the development line. As soon as the draft documents are available, testers should get involved. Yes. So why testers have to involve as early as possible? Because as for example, you say the business analyst, the solution consultants, and developer they get involved and they do it. Yes. But what if the testers they don't get involved and they don't know what to test? How to test it? What to test and how to test it? It will fail. Yes, the project derails. You won't be able to find defects and the software which is developed might be incorrect. The choice of model driven by project or product characteristics, and these characteristic choice of it is driven whatever model you are going to use, it is driven by the project and the product characteristics. How big the project is, how small the project is, how important the project is. Based on that you will select the life cycle, software development life cycle. You can't just randomly select, okay, I want to do it. Yes. But most of the time when you are testing a third party software, that is more sort of waterfall model for you, because somebody is building it somewhere else and you are testing. Yes, the end product is released to you. Like for smart metering, when I was working for the suppliers, it was waterfall model, because LNG, EDMI, they deliver the software and we test in the end. But we used to have 6 weeks release, so still they were using this waterfall model, not waterfall model, agile model. So it is better for us as well. We have certain levels of requirements to be tested, not the whole project the same time. Yes. Any question with this?
No.
So what is the background you have for the test level? Test level background. The specific objectives. Each and every level has specific objective. Yes. As I discussed previously, for component testing, you have objectives for the component testing, and you say that what you want to achieve, what is your intention for component testing. For business specification, you have the acceptance testing, so the objectives are different, and you have specific objectives. The test basis documents. What is test basis? I have explained it. Do you remember? Test basis are the source of document or source of any information from where you derive the test cases. So the test basis can be requirement, as I said, yes, legacy system, etc. Yes, any documents. If you have something else like user stories, then you use the user stories. You have some manuals sold, then you use the manuals. They are all objectives, not objective test basis. The test object, whatever you are testing is the test object. Yes. What is test object? Whatever you are testing means the system. System is for test object for you. If you are testing the document, the requirement document, the object would be the requirement. Typical failures and defects expected. You will always, when you test it, you will find defects. Yes, yes, and failures. Whatever you are expecting, you will find in certain area. Test harness requirements. This is not test harness. This is test harness requirements. When you are automating it, in order to set up the environment, what are the requirements, the tools, and everything you have? Yes, they are the requirement. Tool support. You need to decide what tool you are going to use for any level and how you are going to use. Yeah, that is tool support. Specific approach. What approach you are going to use to test the software. And the responsibility, roles and responsibilities. Who will do what? Yes.
Yeah.
How many team members are there? And in these team members, who is going to what activities? Their responsibilities allocated. As for example, I said yesterday, some people might be analyzing and designing the test cases. Other hand, some might be executing the test cases. Yes. So based on the responsibilities, some people might be just looking after the defects. They are testers, but they are just because there are so many defects, so they just look after the defects and they become defects analyst. Even though they are tester, you call them defects analyst. They have nothing to execute. They won't execute any test case. They will not do any. Just you raise some defects, they will go to these defects will go to this specific person. This particular person will analyze and say that okay, this is the right defect. If it needs, then it will raise to the development team. If it needs to be rejected, then it comes to back to the user. Why there's a defect analyst in the middle? Because sometimes you raise so many defects, the teams are so large with a big project. Yes, you don't know, somebody else might have raised the same defect, so it might be duplicates. Yes, or some other team members might have raised from the different area. He might be our the defect analyst, or it might be incorrect defect you might be raising to some other different. So this defect analyst is there to verify the defects even. Any question with this?
I mean, will there be any role for defect analyst?
Yes,
Oh, really?
yes. They don't
Nice.
do anything else. They just look after the defects.
Okay.
How they look after the defects? I say smart metering. If you have example, 50 testers are there in one team.
Mm-hmm.
All the 50 testers are doing some testing activities and they are raising defects.
Mm.
So you, the 50 people, is a very big team as a you can say yes. So your team member they might have raised the defect. All they might have raised the defect the same time like 10-20 minutes back. So if before it goes to the development team, before it goes to the third party, I would say the defect analyst will analyze literally everything. Some people might not know how to raise a defect, so they might have given incorrect information. Then that if I raise a defect with incorrect information, the developer will reject it. Yes,
Mm-hmm.
in the developer rejects it, then it is coming to and from. This is what happened. I give you example. As for example, you are running a big organization and you have given this IT development to outsource third party, say Wipro, TCS, whatever company, IBM. Yes,
Yeah.
they're developing, they're raising a defect, so they're charging money. Okay,
Okay.
so if you raise a defect and they reject it, they will charge money. If they reject it, said that the incorrect defect raised and it wasted our time. This is the argument. So this is one of the reasons there are some defects analysts. They will literally verify everything. So no duplicate defects, no incorrect defect raised. Even though you have raised a right defect, but if there is no correct information, right information, then the developer will directly reject it from the third party organization. Yes,
Yeah.
and then you need to re-raise it. Even though you raise it, it will be classed as a new defect. And when it is classed as a new defect, what happens? It's more money. They will charge literally everything. It's a money making business. They are paying you, they are paying the developer, so they will just charge, nothing else. Yes? Any other question?
No.
Okay, so levels of testing. What are levels? So one of them is component level. Yes, component testing. So what is component testing? The component testing is also known as unit testing, module testing, or program testing. Unit. These are the synonyms. Okay. Program. Just for example, if you say a text box is a component, a button is a component. Yes. So what is the objective of this? Searches for defects in and verifies the functioning of software modules, programs, objects, classes, etc. that are separately testable. You can test a button separately, yes. You can test a text box separately. These are all. You can test it. For the backend as well, if you have the fields, database fields, so you can check the database fields. What are the test bases for component testing? Component specification. Yes. Detailed design. You have the design how the software will be built. So it's the detailed. So that is called structured, more structured. How the software will be built. They must have given the means in the detailed design. You will how you need to build the code. Detailed design. Code itself. Yeah. When you wrote the code, from the code you can design the test cases. Data model. What type of data you are going to use for that? From these test bases, you can derive the test cases. What are the objectives at this level? You verify that the units are working correctly. So, component units or module, they are the objects. Yes, test objects, units, just call it units. Yeah, classes. What are the classes we are going to use when we build a code? Yes, code and data structures. We have wrote the code, the developer has written the code, and then the code, how the data is being used in the structure. So data structures, and that's why I said databases. So the next one is database models, how the database are created and what are the specifications we have for the databases. Databases is the most important thing to be tested because all the verification or you call it validation that comes from the database. Nothing is done in the UI. The UI is for displaying the messages for the end user. Any question for you? Any
No,
question?
no.
Okay, in component testing, what happens? You have a system. The whole system is broken down into you need to A, B, C, D, E, F, G, H, I, J, K, H. Yes. Yes. For example, if I go on something, uh, okay, so if I open the census form in here, it will have some information there. How you fill the form. Hopefully, it will be here. So if I go not much in detail, this is one unit, but it is so many things. This text box is a unit. This is a unit. There are so many things that direct some different area. They are all independent unit. So when you are testing the specific unit, yes, okay. I don't know whether you are using Yahoo Mail or no. I don't. This text box is a unit. You can separately test it. Yes. The button there is next button there is a unit. Create an account. When you click on create, first name, surname, email, this Yahoo say password, mobile number. These are all separate units, and you need to test them separately. This is known as unit testing. How it is done, the unit testing, how the execution is done. So you have the code now ready, so you can execute the test case. When you execute the test case, what happens? You find a defect. Yes, test. Then you find defects. Defects. Then defects are located. Locate defects. When you locate the defects, these defects are fixed. Yes, and then in the end you do retesting. What happens? You execute a code. You found a defect, you located developer and fixed it and do retesting. Again you find a defect. If you don't find anything, then you close it. Yes. Otherwise, if you find another defect, it starts from here until you close and verifies it. Yes. This activity is done by developers or programmers. Okay. The developers do unit testing, not testers. And because of that, there is no formal defect management. Why there is no formal management defect? Because you are a developer, I say. Then you wrote a code, you tested it, and you found a defect. What is the point? Literally noting everything. Yes, it is like too much admin work. You say, and you are making mistakes, and what is the point telling the third person that you made a mistake and corrected it? Yes, so that's why there is no formal process at unit testing. No formal defect management process. Yes. Do you have any question?
No.
At component level, we can have one approach. What could be the approach? We have the test basis. From the test basis, we can directly write the code. It is for the developers, so can they directly write the code and execute, then prepare the test cases. One approach. Test basis. That's what is test basis?
They write the code.
No, test basis means requirements. You simply understand from the source, you derive the test cases. So it is requirements. From the test cases, you write the code first, yeah, then test cases, and then execute test cases. Yes. Approach 2, you have the test basis. Before the developers start writing, they will prepare the test cases. Prepare test cases. What do? You sometimes automate these test cases even. Okay. And what is third? Write code and execute test cases. So there can be two different specific approaches for the component testing. Do you have any question?
No.
Okay, so there are two approaches. The test developers, when they have the requirements, directly they will write the code and then prepare the test cases and execute them. Or first they will write the test cases and write the code. What is the purpose? There is a two way you can call it test driven approach. So you design the test cases first and then execute. So what is the benefit? You write the code in a way that the test case passes. The test case pass. Okay. Any question?
No.
Okay, let's go to the next one. Component testing. For component testing, you need to integrate two components. Yes. And when you integrate them, it will be component integration testing. So when you integrate these components, you link one component with another component. Yes, link one component with another component. Yes, link component 2. Link component 1 with component 2. So as for example, you have unit A and you have unit B. Okay, unit B is relying on unit A. So when you integrate them, the component A will call component B. Yes, here say unit A calls unit B. Unit B is called by unit A. It's like active passive, but I'm writing in a way that you can understand easily. So unit A is calling, unit A calls unit B, so it is called a calling component. Yes, unit B is called by someone, which is unit A, so it is called a called component. Let me explain you with some of the websites so you will understand. Now, acknowledge is the button. When you fill this all data, yes, you click in here. Let's click on sign in. When you click, this is there, and then you can go to this place here. Yes. So when you integrate certain levels of components, you try and call. Let's for simple enough. If I say just going back and give you login, you do first, yes, and then log out. So login is called calling component and logout is called called component. Yes,
Yeah.
because this is preconditions when you log out. So when you are doing component testing and these components might be missing, as for example, you want to test unit B. As for example, you want to test the logout functionality, but the login functionality is not available. Yes, the login functionality is available and you want to test logout functionalities at the same time. So what happens? These functionalities are not ready, or these requirements are not ready, or these components are not ready, you say. In this case, you use drivers and stubs. Yes, you use drivers and stubs. Drivers replace missing calling components. Yes, drivers replace missing calling component. Practical theory. And you use stubs
Brijesh, what are drivers and
for.
what are stubs?
Yeah, I'm explaining you. Sorry, I got asked. So let's go back to again. As for example, I gave you unit A is calling unit B. Yes. So unit A is known as a calling component and unit B is known as called component. Are you clear with this concept?
Yeah.
Now you want to test unit B. Okay. Your requirement is to test unit B. Test unit B. But as unit A is missing, you need to replace because you want to test it and unit B is rely relying on unit A. Unit B is relying on unit A. You cannot test unit B without testing unit A. Now unit A is not developed. So you replace it as a, you have a pseudo code, some placeholder. You use a placeholder that is called drivers to understand easy. Now you want to test unit A, yes? And as a part of that, you are testing unit B as well. But unit B is missing. Unit B is missing. You are testing the whole sequence, but unit B is missing means has not been developed. That means, okay. So if it is not developed, what happens? Can you test log out and log in together? Log in and log out. You want to test login and log out both functionalities together, but the log out functionality is not available to you. So you need to use placeholders. When you use a placeholder, it is called a skeleton, okay? Placeholder for a calling component, not calling component, a called component, okay? Placeholder for a called component. Whatever placeholder you use for a called component, you call it a stub or stubs. Clear?
So you said unit B is a called component, right?
Unit B is, yes, a called component.
So if A and B are not there,
A and B both are not there, then you
yeah,
can't test it. That means you don't have anything ready. Yes,
okay,
at least you need to have something ready to test it, and you started testing. So let me draw you something here. It will make more sense. I'm just randomly, so there is forget about the size difference. Okay. So here something that this is unit A, B, C, D. Yes,
hmm,
it might allow me to type here. Yes, same thing. B, C, D, E, F, G. These are the components you have in here. Okay. Now I'll just use the stick. There must be some arrow there, but not available. That's fine. So A is calling B, A is also calling C, and A is also calling D. Yes. B is calling E, C is calling F, C is also calling F, C is also calling G, D is calling G. Yes. Now, as a part of your testing, you are testing A, B, C together. A, B, and E. Sorry, A, B, E together. So this flow A, B, and E. You are testing A, C, E. You are testing A, C, F. You are testing A, C, G, and you are testing A, D, G. So this is the flow you have. Like as for example, transfer money from your account to someone. So you log in into your account, go to my account, add the recipient, yes,
yeah,
and transfer the money. So this is the flow. In this flow, what happens if A is missing here? Okay, you have B ready, E ready, C ready, F ready, D ready, G ready. But A is missing. A has not been developed. So you use a skeleton module called drivers. Yes.
yeah,
Now A is ready, B is ready, A is ready, C is ready, A is ready, D is ready. But E is not ready. Then you want to test A, B, E in a sequence, and for that you use stubs. Yes.
okay,
As for example, A is ready, C is there, F is there. Yes. So, and for example, A to C, but C to E. So that you need to go in the flow. So first or end, and that is known as stubs and drivers. Any question?
no,
Okay, let's go to the integration testing. So what is integration testing? I have discussed it today itself. So let's discuss component A. You have two components, component A and component B. Yes, you have integrated them. Yes, so that is known as integration testing. Now you might have two separate systems. Yes, this is system A and this is system B.
yeah,
So when you integrate those softwares, then it becomes software integration testing. As for example, you run a big business, then you might rely on different softwares. Yes, as for example, the banking software, do you think that it is one software? The website you see is one part. It might have a different database. They might be managing their internal employees with a different thing. Yeah, they all should be integrated. That's what called system integration testing and component integration testing. So how does this work? Overall, whatever you can see is the interface. Yes, the communication between two systems. For in the bottom, you have the database management system. So everything comes from the database. The database is connected with the application software. Yes, whatever application software you use, Java or any Oracle or anything, you link with the program. Oracle means database management system. Then software environment. What software you are using? Yes, your domain. And then comes the hardware environment. What hardware you have? What type of configuration you are going to use with the hardware? Yes, all processors and everything, they are part of hardware. So they are all part of integration. One is component integration testing, another is system integration testing, and some kind of hardware or your software. So they are all integrated. Yes. Any
Yep.
question with this?
No.
So in integration testing, what are the bases? Test bases. Can you tell me? The test basis for integration testings are software and system design. How the software, how you are going to build the software. The units are there, unit 1, 2, 3, 4, 5. But this is not a software. You need to integrate them. Then and then you will have a software. Yes. As for
Yep.
example, you are making a car. Steering wheel only is there. Can you drive? Can you go anywhere else? You have
No.
just one wheel. No. You have windows. You have glasses. Everything there integrated to make a car. So in terms of software and system design, how the whole software will be built, and for that we have a design called software system design. Architecture, how the software will be built and works, that is a work of architecture, and that's why they get more money. When you have more experience, you tell the developers how you are going to build it. Workflows, what are the processes you have? Yes, they are all workflows, from where the work comes to the flow wise. Use cases is a part of requirement only. It is written in a interaction between user and actor, no, actor and the system way. So I will explain you in the requirement section in detail. Sequence diagram, how you must have heard the sequential flows. Yes, when it flows the processes, what are the sequence? For that we have the diagrams, and they are known as sequence diagrams. What are the objects? What are you going to test in here? So you say systems, subsystems, and databases, because you are integrating the databases. Yes, infrastructure, the whole structure of the software. Interfaces, yes, the relation between two systems, how it communicates. APIs, application programming interface, how the application programming interface responds, how you derive the data from the database, how you derive from the data from the servers. They are all known as APIs. Any question?
No.
So for component integration testing, you can have three different approaches to test them. Three different ways. Okay, approaches or ways. One. What is one? One is you integrate component A with component B. Yes, component A with component B and component T. If you do this one, that is called incremental approach. This is recommended. It starts from top to bottom. So that is also known as top down approach. Yes. If you integrate from E, B to A, this is also incremental, but you are doing opposite way. E, B, A. Yes. Then it becomes bottom up approach. Yes, it starts from bottom to go up. So it becomes bottom up approach. And for that, you are testing the functionalities of this. So that is known as functional task or functional approach. Another is you bunch everything together. Yes, and everything like A, B, E, A, C, F, whatever, and you test it. What would be? You tested is no, you integrated same thing together and testing it. Yes. So what happens? It is known as Big Bang approach. It is not recommended. You have so many. So there are three ways like bottom up, top down, and Big Bang. In that, you test everything together. But it becomes very complicated. It becomes difficult to isolate a defect when we use bottom up or not Big Bang approach. When we integrate these modules one by one, these components one by one in bottom up or top down, it is easy for us to identify defects. Any question?
No.
Okay. Let's go to system testing. What is system testing? So we have the system requirements, what the system should do. Yes. For that, we need to do testing, verify the system functions as per the expectation, and that is known as system testing. The process of testing a system to verify that it meets specified requirements. This is ISTQB definition. The process of testing a system to verify that it meets specified requirements. What are the test bases in system testing? The test bases in system testings are system and software requirement specification. How this specification will tell you the functionalities of the system, the functions of the system. Yes. Use cases. What are the use cases? As I said, if in an one sentence, it is an interaction between an actor and the system. So how? Tell me. I explain you use cases. Otherwise, you write the requirements in the interaction way. Yes. As for example, you are using ATM. How you write? Yes. Requirements in the use case management. You insert your card. What system does it? Verifies your card. Yes. Then
Mhm.
ask for the PIN. As a user, you enter the PIN. What system it does? Authenticates the PIN. Yes. And then displays the option. What are the options there? Then you select the options as a user. And then if you are withdrawing money, then the ATM will dispense the money. If we are asking to PIN change some other activities, then accordingly the system. So it is an action between system and the actor. You can literally write use case for everything. How to use a toaster, how to make coffee using a coffee machine. Yes, this is all because you are using a system. Whatever coffee machine is a system and you are actor. So the interaction is done between you and system. If you write in this action way, then it becomes a use case. Understood?
Yeah.
Models. You have the model of the system. State diagrams. How the system will work. Based on that, you have some diagrams available. Risk analysis reports. The business analyst might have provided you, the project team might have provided the risk analysis. What are the risks the system will face? The reports are there. From there, you design the test cases. Apex or user stories. Apex means a big requirement in simple way you can understand. This big requirement you can break down, or these requirements are broken down into small user stories. Okay. If you write given v1 then format in, then it would be a user stories. What you exactly want from the requirement or a specific requirement, You write in a given when, then cucumber format, then becomes user stories. System and user manuals, as I said earlier, sometimes you don't have anything, you have the user manuals. Yes, from the user manuals you derive the test cases. So these are the test basis for a system testing. What are the objects what you are going to test in the system itself? Yes, so the application. Operating systems, why operating systems? Because the particular software is going to work on a particular operating system. Yes, if it is going to support multiple operating systems, then you need to test them, different operating systems. As for example, that for iPhone is we have iOS. For this Windows, we have the Windows, means any laptop, most not any laptop. For most laptops we use Windows. Yes, not most, but Toshiba all others. So it's a Windows operating system. It has so many. Windows 10 is now Windows 8, whatever it is. Yeah, XP used to be then. System configuration. How we are going to configure the system, that we need to test. And system and the test. The system itself we have to test. Concerned with the end-to-end behavior of the whole. As a whole, what you are testing? End-to-end behavior of the whole system or the software. Do you have any question?
No.
Okay, how we can do system integration testing? As I said earlier, we have the database management system. For the database management system, the application software is there. What programming languages are used to build this? There are no. Software itself, the software environment. What is your software does? It's your own software application you are building, and the hardware. What are the hardware requirements you will have to build the software? Yes. Can you build the software without hardware? Otherwise, it won't work. As for example, if you have a software which needs 8 gigabytes of RAM
Mhm.
and you have only 2 gigabytes of RAM, then will it work? No. So this is hardware requirement you have to say. System testing can be both functional and non-functional. What is functional? Functional means the functionalities. Non-functional is not the functional. It is, if I have to explain you in a simple way, what you are doing with the system is a functional. Non-functional requirements are volume, load. These are the specifications. How many users can log in the same time? How much speed the software has? Yes, they are all non-functional requirements. Volume testing, stress testing, load testing, they are non-functional. So this in system you are going to do both functional and non-functional testing, and they are all based on the risks. What are the risks the system will face? Requirements. You do both functional and non-functional testing on the requirements. Business processes. Yes. What are the business processes we have? Or the business processes provided to you. Based on that, you will design the test cases and you execute them. In the requirements, the second says requirements and the risks, both of them. It could be both non-functional requirements and functional requirements. Security threats, yes. Requirements, how many users would be there to log in the same time? How many users will be there to do the exact transaction the same time? There can be this kind of requirements as well. Business processes, how or what business processes the users are going to use. Use cases and scenarios, what are the use cases you have? Interaction between users and actor and the system, and the scenarios you are going to test. Testing bank balance is one scenario, but in that you have low level. Withdrawing money, cash from ATM, withdrawing money from bank. Yes, paying someone, transferring money, transfer money from one to another account. These are all scenarios. Models. What are the models we are going to use for the software? And this system testing is often done by an independent test team. So if you get a job as a specialist tester, you end up in a system testing, user acceptance testing, all other areas. But this is done by independent testing. So for that, the testers are must. The developers don't do this testing. Do you have any question?
No.
Do you want to stop it? If you want, we can
Okay.
stop it or we can carry on. We are moving to the next section called acceptance testing. It is up to you.
Yeah, we'll do it tomorrow.
Okay, then. Okay, so then see you tomorrow around 9 o'clock.
Okay.
Because
If you want, we can take it early.